Alrighty, I think we can get started. Thank you all so much for joining me today. My name is Kukic. I am the Director of Developer Advocacy here at DigitalOcean. And in this workshop, we're going to be talking about managed databases on DigitalOcean. I want to extend a warm welcome to everybody that's joining me today, all the way from Greece, Norway, the US, and many other countries. So it's great to see the global DigitalOcean audience turn out. So let's get started. An overview of this workshop, we're going to learn about managed databases on DigitalOcean, what the various options are, how to work with managed databases, why you would want to work with managed databases, and much, much more. We're going to understand managed database use cases, and then we're going to compare two different database engines that DigitalOcean supports, a SQL option with PostgreSQL and a NoSQL option. And in this case, we'll be looking at MongoDB. But as always, we support additional database engines with MySQL and Redis. And pretty soon, we're also launching a managed Kafka service. And while Kafka isn't a traditional database of sorts, it is more of a event, streaming platform. It can still be used as a database. And if you're interested in learning more about managed Kafka, I have a link on the screen here for you to sign up and get information as we get started. So, like I said, I want to make this session as interactive as possible. So please feel free to ask questions, leave comments in the chat, and I'll be checking them occasionally. I also have a great team of moderators supporting me, Akil and Aishika. So let's make this workshop as interactive as possible. Now, when it comes to managed databases are really a way for you to deploy a database without having to manage it yourself. And at DigitalOcean, we support, at the moment, 4 different database engines: MongoDB, PostgreSQL, MySQL, and Redis. And like I mentioned, we'll be getting managed Kafka in the next couple of months as well. So when it comes to a managed database, why you would want to do it, when it comes to building your next great application, all applications have to store data somewhere. And you as a developer, you as a business owner are, have to decide whether you want to self-host your database, manage it yourself, or if you want to use a managed service like managed databases from DigitalOcean. And if you decide to go the self-hosted route, you are responsible for installing and managing the database. You're responsible for maintaining, upgrading, handling backups, and you also have to ensure that you have to ensure that you're following the licensing and compliance with that database engine. Some database engines have community versions and enterprise versions, and you have to make sure that you're using the right one and you're not in violation of any of the licensing terms. Whereas when you go the managed route, you basically select the type of database engine you want, the version of that engine, the size of the database you need, how many resources for that engine. Once you've made your selection, you get a connection string to connect to that database, and all of the maintenance, all of the upgrades, updates, backups, and everything like that is managed by DigitalOcean. So we are responsible for ensuring that your database is running optimally, is available, is reliable, and you can, you simply just use the connection string to connect to it. Now, some of the additional benefits of using a managed database service is that you get point-in-time recovery. So with DigitalOcean, you get daily backups. And if your database gets corrupted in the future, you can go back in time to a version of the database that worked and easily roll back. You can additionally, you get free daily backups. You get automated failover and failback. So if a server goes down or if one of our data centers goes down, we have a failover strategy to ensure that your database does not Additionally, you get automated maintenance, so minor version updates can be automatically applied and your database version upgraded without you having to worry about it or manage it. You just set a time frame for when you want DigitalOcean to manage that for you. And then finally, zero downtime scaling and forking of the database. So if you decide that the database that the main database server that you launched isn't meeting your needs anymore, and you need to either increase it or decrease it, then you can do that with zero downtime. DigitalOcean will do all of that in the background to make sure that the image is resized and that you can access it properly. Now, if you decide to go the self-hosting database route, you'll come to find that it is hard work. I myself come from, before joining DigitalOcean, I worked at MongoDB, and part of my onboarding at MongoDB was learning all the ins and outs of setting up a database. And it is work, and there's so many things that you can misconfigure, so many things that you can do wrong. So going the self-hosting route, you really need to know what you're doing before before you embark on that journey. And some of the steps are to first go and install the server software, and that's pretty easy. Go to MySQL or go to MongoDB, download the image for your operating system and install it. But after that, you have to set up the server, and that means setting up the permissions and services to ensure that the database server starts up properly. And then you have to update the configuration file to match your needs exactly. With MongoDB, for example, you have to set up the MongoD daemon, the Mongo S processes, decide if you're going to use sharding or not, journaling, how to do backups, how to do very, very many different configuration options to ensure that the database is running optimally. And then you deploy that database and test it to make sure that it works. And then you go back to the setup to do it again for your dev environment, for your testing environment, for your production environment. And you're very likely, not going to get it right the first time. So you'll have to spend a lot of time tweaking the configuration files, tweaking the configuration options before you're able to actually make use of that database. So all of that time is spent managing your database instead of writing code and writing your next great application. And that's what we want to avoid. That's what we want to enable with a managed database service. Deploying a managed database, on the other hand, is fairly easy. In the DigitalOcean dashboard, you simply choose a region where you want your database deployed, the database engine, and how many resources you want to give to that database engine, how much RAM, how many CPUs, how much hard drive storage, and things like that. Next, you configure additional options such as, in MongoDB, for example, if you want a replica set, so if you want multiple nodes, or, in Postgres, if you want read-only nodes as well, you can set that up. And then you click the Create Database Cluster button. And within a couple of minutes, you get the connection string to connect to your database. You can know and trust that DigitalOcean deployed it in the most optimal way. And then you can just get to writing your queries, adding your data, and building your next great application. So today we're going to look at a sample application, a very, very simplified e-commerce store that we're going to use throughout this workshop in various different ways. And what I want to do is in addition to showing you how to deploy and manage a managed database in DigitalOcean, I also want to teach you a couple of things, a couple of differences between SQL databases and NoSQL databases. So we'll write different queries, we'll use different tools and software, and hopefully have some fun. So before we get into our sample application, let me check the comments real quick to see if there are any questions. So far not too many questions, but Corey did say that he loves setting up his own databases, and yeah, I mean, if you enjoyed that is great. I myself, coming from a database background, sometimes do like to go in and manage the database server myself. But when I'm trying to build an application and just trying to get some code out quickly, I often opt out for a managed solution myself. So when it comes to our sample application, the e-commerce store that we'll be building is going to have four different tables or four different collections in the MongoDB example. We're going to have our customers who are going to be purchasing items. We're going to have products, which are going to be the items that our customers purchase. We're going to have vendors who create the products. And then finally, we'll have an orders table, which lists the different orders that the customers have placed from the various products that they can buy. Now, I did see a question from Andres, and sorry if I mispronounced your name. And he asks, do you offer serverless databases, or do they have to be provisioned instances? So they are provisioned instances. It's not, at the moment, our offering is basically provisioned databases, whether it's a MySQL, Postgres, MongoDB, or Redis. That's a good question. So in our sample application with our customers collection, on the left-hand side, we have the MongoDB data model that we're going to be working with. And then on the right-hand side, we have the Postgres table. And you'll notice with the MongoDB example, it very much looks like a regular JSON document, right? You have key value pairs for the various fields or various attributes in your document. In MongoDB, rows are essentially called documents, and within each of the documents, we have fields. So we have the full name field for this customer, Willie. And then one of the big benefits of using MongoDB is that your data model looks exactly the same like how your application might use it. So, if we were to just call this customer's record, we could work with it directly because it is represented as JSON. As JSON data. So in the MongoDB database, it's stored as BSON, but when we call it and get it into our application, it gets converted into JSON, and we can very easily work with this data. We can nest it, like the address field, for example, here is an object that has additional fields or attributes within it. When it comes to our Postgres, our traditional SQL layout, we have rows and tables, right? We have a table that has rows, and the columns dictate the different data types. So we have an ID data type, a full name, and then our address is represented as address _ street, city, state, and zip code. Now, one of the big benefits of MongoDB as well is that we can change our data model at any time. So for example, if we wanted to store multiple addresses in our customers' collection, we can change this address field to an array and then store objects in that array that represent the current address, the previous address, or we can easily add an additional address property that that will be like previous address or previous two addresses and so on and so forth. With Postgres, it's a little bit harder to do. Like we could use a JSON data type for the address and then store it kind of in the same way as MongoDB, but then we don't get all of the niceties of the SQL language, where we can very easily query, join things together, and work with our data. But when we get to some of the examples, you'll see that both MongoDB and Postgres, both NoSQL and SQL databases can be used to achieve pretty much the same results. On our products table or our products collection, we're going to have a products with the name of the product, their price, their quantity, and who the vendor is. And in my case here, I represented the vendor as an object, basically as an ID. And in the traditional MySQL world, SQL, whether it's MySQL or Postgres, you would do this. You would do this often because you would want to normalize your data in a way where vendors would be represented in a different table. And I did this for the Mongo example as well, just to show you that that is a possibility and that is a capability of both MongoDB and Postgres. But we could have just as easily made this vendor field an object and stored the vendor information directly in the products collection in MongoDB. And whether you store it as an object or you store a reference to the vendor in a different collection is totally up to you. Our vendors are pretty simple. On the MongoDB side, we have just the vendor's name and the items that they produce stored in an array. But in our Postgres example, we're going to have just the ID of the vendor and their name, and we're going to use joins to combine that data when needed. And then finally, for our orders, since these are going to be much bigger fields, we're going to look at these live. So we'll close out our presentation and now get into our application. So let's get into some code. The first thing we'll do is deploy our managed database. And before we do that, let's see if there's any questions in the comments. So Corey asks, do you prefer MongoDB or Postgres, SQL versus NoSQL, or is it more of a project-dependent choice? Are there performance differences between DigitalOcean managed database types? And this is a really, really good question, Corey. When it comes to preference, MySQL, NoSQL versus SQL, I think it's very much dependent on the type of application that you're building. Personally, I have a lot of experience working with both MongoDB and Postgres and MySQL. And usually, I'll use the right tool for the job. If I anticipate that my data model is going to be very relational, I'll often go with with Postgres. But if I know that my data is going to be mostly non-relational, and I just want to represent it very easily, or I just want to prototype and quickly build something, then going with MongoDB's much more flexible data model is the option that I'll opt for. But really, at the end of the day, it is a personal choice, and depending on what you're more familiar with, go with that. I think at this point in MongoDB's life, it is a very, very capable database that can be used for particularly almost any use case. So there's no wrong answer there, unless your data is super, super, super relational and can't be joined together. Then Mongo might not be the best option. But when it comes to performance differences between DO managed database types, I've worked with both of them at DigitalOcean pretty significantly, and I haven't noticed a big difference. And actually, when we write some queries, we'll write some Postgres and some MongoDB queries, and you'll see that the results are going to be pretty instantaneous for both. But we'll get to that in a little bit. So I created this new project called Deploy-Workshop, and I've already deployed a Postgres and a MongoDB database. But for completeness, let's also do it live here to show you how to do it. And to create a managed database, you can either go to the databases section in the left-hand side of your dashboard. Let me zoom in a little bit so it's easier to see. Or you can just click this big create button in the top right-hand corner and create a database cluster. And from here, to deploy a database cluster, the first thing you need to do is select the data center region where you want your database to be hosted. Since I'm based in Las Vegas, the closest data center to me is San Francisco, so I'll keep it at that. But you can deploy it in New York, Toronto, or if you're in Europe, we have London, Amsterdam, Frankfurt. Asia, we have Singapore and Bangalore, and in Australia, we have the Sydney data center. And when it comes to choosing a data center, my recommendation here is always to deploy your database in the same region where your droplets or where your app platform apps are going to be hosted, because in that way you are able to have your database as close to your application as possible, which is going to help reduce latency and make sure that latency is as small of a factor as possible when it comes to accessing your data. Once you've selected a data center region, the next option will be to choose a database engine that you want to deploy. So we currently have 4 database engines: MongoDB, PostgreSQL, MySQL, and Redis, and we'll be getting managed Kafka in the next couple of months. And then additionally, when it comes to choosing the database engine, you can also choose which version you want. Currently with MongoDB, we support Mongo 5.0 and 4.4. With Postgres, we support version 14, 13, 12, 11, and then MySQL 8 and Redis version 7. From here, once you've chosen your database engine, you choose your plan. And you can go as simple as the starter $15 a month plan, which is what I'm going to be using for this workshop. But depending on your needs, the needs of your application, you might go with one of the pro plans. And we have additional plans that are much more optimized for different use cases. And when it comes to MongoDB, you can additionally make it a highly available database cluster by adding 2 standby nodes. And what this is going to do is it's going to ensure that if, for whatever reason, one of your MongoDB nodes goes down, another one can immediately take over without you experiencing any downtime at all. But by default, you can just start with one node and then add additional nodes in the future. And for me, when it comes to developing and testing an application, when I'm just being a developer and I'm prototyping or I'm building out the application, I usually just keep it as simple as possible because I don't need high availability until I go to production. And then finally, you can give your database cluster a name, add it to a project, or add any additional tags that you might care about, and then hit that Create Database Cluster button. And in doing this, your database is going to be provisioned, deployed, configured, and in a minute or so, you're going to get the connection string to connect to your database cluster. So I will scroll up, and let's go back and see our databases that we've already deployed. So I've gone through this process for both a Postgres database as well as a MongoDB database. And once your databases are deployed, you'll see a green check mark or a green dot saying that the database is online and good to go. So if we click into the MongoDB one, we can take a look, and I'll hide this and see what the experience looks like. So within the MongoDB managed database that we deployed, the most important part is right here on this right-hand side, which is where we're going to get our connection string to connect to our database. So we can connect to it either via the connection parameters, or we can easily just get a connection string, and I'll show my password for now. But because this database will be destroyed after the workshop, but we'll copy the connection string, and that's all we need to connect to our managed database. Now, the other important thing is this trusted sources option. And trusted sources, at the moment, you'll see that my cluster is open to all incoming connections. And what this means is that anybody that has this connection string, this user, this password, can access my MongoDB database that I deployed. But I can prevent this. I can secure this database by restricting access, by setting up a trusted source. And here I'll set it to my current computer's IP address and save it. And by doing this, now only my computer, only my IP address can access the MongoDB database cluster that I've created. And we can additionally add additional data sources, like such as our applications. So I've also deployed an app platform application that I want to be able to access my MongoDB cluster. So here we'll say, I believe it's called Orca app. Yep. So Orca-app. I'll hit save. So now both my application and my local development environment can access this MongoDB database and nobody else. And you can also see that the upgrade window here is set to automatically apply updates Thursdays between 6 p.m. to 10 p.m. Pacific Standard Time. Additionally, in this dashboard, I have my insights to be able to see what's going on with my MongoDB database cluster. So I can see it over a 1 hour period, or let's say a 24-hour period. And I can see what my CPU usage looks like, what my load average is, what the memory usage is, as well as what the disk usage is. And since I spun this database cluster yesterday and added some sample data, you'll see these temporary spikes in both memory usage, load average, and CPU usage. And additionally, I can also see my logs. So I can see which applications have connected to my application, what queries were run. So these are the recent logs from MongoDB, and they update in real time. So as soon as a connection is made or a connection is ended, I get that information. And then additionally, I can manage my users and databases. So currently I have 2 databases, an admin and a deploy store database created, as well as 1 user. And the same process works for my Postgres database. It's slightly different in some of the visual tweaks, but if we quickly go into it, we'll see that this is my PostgreSQL database. Same thing, I get the connection parameters, I can set up the trusted sources, I can see the version. I haven't added any read-only nodes, but that's okay for now. And I can see my insights over the last 24 hours. Give them a second to load. And this is where I imported a lot of data into the database. So you'll see those spikes there. And then you'll see how over time I've added documents and used up more disk space on the Postgres server. My logs and queries with a SQL database, we can actually see the currently running queries as well as query statistics showing what query ran, how many rows it affected, and then some data about how long that execution took. So lots of queries, lots of information, as well as the recent logs from the database. So all of that is available in the dashboard. I can also set up my users and databases if I wanted to create additional databases or additional users. And with Postgres, I can set up a connection pool to make it easier using a PG Bouncer to have an active pool of connections at the ready. And if those get exhausted, then no more connections can be made. Settings, same thing like the trusted sources with MongoDB. If I wanted to limit access to my database by a certain IP or by a certain DigitalOcean asset, I can do that here as well. Just checking on time. It looks like we are good. And this database is deployed in the San Francisco region as well. So I've used for both MySQL for both Postgres and MongoDB. I just went with the simplest option: 1 GB of RAM, 1 virtual CPU, and 10 GB of disk space, which should be enough for this workshop. Now, before we get into the code, let me take a look at the chat really quickly and see if there's any questions. And like I said, please feel free to add any questions, any comments as you have them, and I'll try to stop every 5-10 minutes to address any feedback. And cool, it looks like there is no questions at the moment. Or Neil asks, Postgres version 15. So at the moment, we support up to version 14, but we're definitely on the lookout for version 15 as well. So when we do release it, we'll update it in the blog and in the documentation as well. Cool. So next, we have these two databases deployed. Sorry, I just saw another question. So can there be data segmentation? I saw it in another presentation, but not yet sure about the concept. What do you mean by data segmentation? That there's various ways we can segment. So as far as data segmentation, we can create projects which allow you to host different resources, basically tag different resources in the dashboard. You can additionally create different teams in the DigitalOcean dashboard, which will allow you to separate, like if you only wanted to have access to a certain database, for you or your development team, you could create a different team for production, staging, QA, and things like that. So in that way, you can segment it. Additionally, you can also segment it in the databases as well. If you create additional databases, then you can store data in a particular database. Another question that we got, do you plan to add more metrics to DigitalOcean MySQL managed databases? We use MySQL Workbench dashboard to get a quick look at our DB. And here are the additional metrics available. Buffer pool, usage, read requests, write requests, disk writes, disk reads, table open cache efficiency, incoming network traffic, outgoing network traffic. This is a really, really good question. And I don't have a good answer for that, but I will take this and share it with my project manager on the managed databases side and see if that is something that's on the roadmap. But we're always trying to make our products simpler to use and offer more information for our customers. So that is a great suggestion. Cool. So before we get into writing some code, let's see how we can connect our Postgres database. So we have our Postgres database here. And like I said earlier, we have the connection parameters here. We have the username, password, host, so on and so forth. And we can connect to our database either through an application, which we'll get to in a moment, or through a GUI tool. And in my case here, I will be using DataGrip as the tool to connect to the Postgres database. So here is the properties that I added to connect to it. So we have the database Postgres DO user as the host, which matches up here to our host. Our port is 25060. Likewise here, 25060. We have our user DO admin, default database, and then the password that we added. Once we do that, we'll see that we are connected to our default database, and we have our 4 tables created. The customers table, which has close to 100,000 records. So if we go all the way to the end, we'll see we have 97,440 records, and they match what was in the slide presentation, where each customer has an ID, their address information, as well as their full name. We have our products. And actually, let me zoom out a little bit here. Just to make it a little bit easier to read. Let's see, window. That's okay, I'll just move these things. So we can see for our products, we have the ID, the name, the price, the quantity, and the vendor. In our vendors, we have an ID and the name of the vendor. And then for our orders, we have the order number, the date that the order was placed, the customer ID that placed the order, the total amount of money spent. And here with Postgres, we're also able to use arrays. So we have an items column that is of a data type varying characters, an array of varying characters. So essentially an array of strings which represent various orders. So each order has multiple items ordered, or in some cases a single item ordered, and we represent them in the items array here. So that's how we can connect our managed database to our managed Postgres database to DataGrip, but we could use similar tools like, somebody mentioned MySQL Workbench or any of the various GUI tools for working with SQL databases. I just prefer DataGrip as I'm a big IntelliJ fan. When it comes to working with our MongoDB database to connect to it, let's see how we can do it easily. So we'll go into our managed MongoDB database instance. And we'll just get the connection string. Well, again, we'll show the password, copy it, and then we'll go into MongoDB Compass. And I'll disconnect here for a second. MongoDB Compass is the official GUI tool for working with MongoDB. It's created by the MongoDB company. So if you wanted to visually work with or inspect your MongoDB databases, whether they're hosted on DigitalOcean, self-hosted, or hosted on MongoDB Atlas, you can use MongoDB Compass. And to connect, you simply provide the connection string. So we'll paste the connection string here and hit the connect button. And we're off to the races. We're good to go. So here I have my deploy store database, which also has instead of 4 tables, it has 4 collections for customers. And we have 100,000 customers with their ID, their full name, as well as their address. We have our orders, which has the ID of the order. So in MongoDB, you're always required to have an _ID field. And we just default this to an object ID, but we're also saving an order ID or an order number, the date when the order was placed, who the customer is, and in this case, we're storing the entire customer object, not just a reference to the customer that has their full name as well as the address of where to ship the order to, as well as the individual items purchased. And in this array, we're also storing all of the item information, such as the item's price, quantity, what the item was, as well as their object ID. Unlike in the PostgreSQL example, where we're just storing the ID. So if we wanted to get information about the product that's being sold, we would have to join on the products collection to get that information. But with MongoDB, we can very easily just embed that in the array. And then finally, we have the total spend, which in our case here is 5,756 for this order. Our products collection has the product information as well as the quantity. And our vendors, here we have the vendor ID, the vendor name, and the items that the vendor produces. And here I explicitly made the choice to only store the object ID. And I wanted to do this to show you that MongoDB can also handle relational data, and you can do joins in MongoDB. They're called lookups to combine data from various collections. And so, this was a very explicit decision to just store the object ID and not the whole object information. Cool. So Rich says, how great is this? Lots to take in right now. Hopefully we can watch these back or get some kind of summary or conclusion. Absolutely. We will post this whole video after the fact, and I'll also share all of the code, the slides, and examples if you wanted to play with it yourself or follow along yourself. Cool. So now, we have our data in both MongoDB Compass and Data Grip. And from here, we can write, all sorts of queries. So we can say, in our customers collection, let's say we just wanted to find customers that are based in, let's say, California, for example, right? So we can write a query that says, get me all of the customers that have an address state that is based in California. Now, if we run this find operation, we see that our number of documents went from 100,000 to 1,997. And if we look at the address property for all of these customers, we'll see that their state is always going to be California. Likewise, if we wanted to run that same query in the MySQL world or in the Postgres, we could just write a query saying select all from the customers table where the address state is California. So if we run this query, we'll see that now all of these customers have their address state set in California, and we can see that we have over 501 records. If we scroll to the end, we'll see that in our Postgres example, we have 1,950 customers that are based in California. And you can see that both of these queries run pretty quickly in a matter of milliseconds. This one took 77 milliseconds. The execution took the longest, 53, and then fetching latency for that data was only 24 milliseconds. So these queries, whether they're on MongoDB or Postgres, execute very, very quickly. And here we have about 100,000 records in each of the databases, and we haven't created any indexes or anything like that, and we're still getting pretty fast execution. So that is how we can work with our data that is stored in MongoDB, that is stored in our DigitalOcean managed database. We don't have to worry about where this database is hosted, how it's hosted. We can just work with our data. We can insert new documents. We can query documents. We can understand our schema a little bit better to see the type of data that's in there. And another really cool feature with MongoDB that many people are not familiar with is this concept of aggregations. And what aggregations allow you to do is essentially do joins in MongoDB. And I want to show you one example of this. So I'll close out this field here, and let's go into the products collection. So in the products collection, we have this, we simply have 5 fields: the ID, the name, the price, the quantity, and the vendor. And the vendor field is an object ID that references a particular vendor in the vendors collection. Now, in the MySQL world, you could do that very easily with a join, right? So if we go into Data Grip, we can say select all documents from the products collection, and we'll do a left join with the vendors table, and we'll join that on product.vendor is equal to the vendor's ID field. I think that looks right. So if we execute this, in the MySQL world, we'll see that we have our practical wooden car. The vendor ID is so-and-so, and the vendor's name is, this particular Strack, Hartman, and Rice, Torp Group, et cetera, et cetera. And if we remove this left join, just copy it for now, execute the query. By default, if we just get all of the all of their data from the products table, we don't get the vendor name, we don't get the vendor information, we just get who the vendor is. But by adding that left join, joining the vendors table, and re-executing the query, we get the additional vendor ID and the vendor's name field. And this vendors.id is a little bit redundant since we already have it in the product. So if we were to rewrite our query, like product, get everything from products, but from vendors, just get the name, we can simplify that query a little bit so that we still have the vendor ID, and then the vendor's name is joined to our collection. In the MongoDB world, for the longest time, one of the drawbacks of using NoSQL is that you couldn't do joins, you couldn't combine this data. So if you wanted to populate this vendors field, you would have to make an additional call to MongoDB, an additional query to go and get that data. But with an aggregation, we can actually do this on the MySQL database server. And to do this, we'll go into the aggregations tab, and we'll do a lookup aggregation. And so we're going to be looking up, what a lookup does is it does a left outer join. So we're going to go into the, let's see here. We're going to go into the vendors collection, and the local field that we're working with. So let me redo this just because it tends to be the helper information is actually running the query. So for that reason, it's pretty slow. But if we remove these and now add them back in, so our local field is going to be the vendor object, and the foreign field. So in the vendors collection, it's going to be this particular vendor ID. Did I lose it? Okay, so we'll go back to the aggregation, do a lookup, and let me remove the helper fields. So we'll say go into the vendors collection. Our local field is vendor. The foreign field is going to be the ID. And we'll just replace the vendor item, or we can say vendor full. And now we can see that we added an additional field in our aggregation to give us the object, to give us who this vendor is and what additional items they produce. So that's how you can do essentially, quote unquote joins in MongoDB using the lookup operator and an aggregation. Cool. So enough playing in the GUI tools. Next, let's jump into some code and show you how you can easily connect both of these managed databases to your application, right? We're all developers. We like building code, and we like doing things programmatically. While the GUI tools are great for learning and exploring our data, we want our users to be able to make use of this data. So I'll close both Compass and DataGrip, and I'll forward you to this GitHub directory called Deploy Workshop, and I will share this in the comments as well. And before we get started, let's see if there's any additional questions. Eric asks, how do I add database extensions like PostGIS for Postgres to perform spatial analysis? That is a very good question, Eric, and I will have to follow up with you on that. I know there's a way to enable features using the DigitalOcean API. So you can you basically just go into the dashboard, get your API token, get your personal token, and then you can make calls to the databases endpoint, which allows you to enable and disable certain features. I'm not 100% certain if PostGIS, the extension, is available through the API, but I will double check on that and get back to you. So getting into our code example, we're going to be building a simple Node.js application. And if you want the data set that I was playing around with in both MongoDB and Postgres, you can find it in this data directory. It has a number of JSON files as well as a faker generate dataset script that you can use to generate your own fake data. And these are just really big JSON documents. We'll have to view them raw because they're 20 plus megabytes each that have the data that I imported into our collection. So you're free to use this data or free to generate your own data if you wanted to follow along. And if you wanted to clone the GitHub repo, you could do so easily. I already have it up and running on my local machine here. So let me pull up Visual Studio Code and walk you through the code. So I've downloaded the data, but since I've already imported into my databases, I don't need it. The one thing that you will need to do is take this .env.example directory and rename it or clone it to be .env. So just get rid of the .example. And here, you just add your connection strings that you get from DigitalOcean's dashboard. So I have my MongoDB URI, and I have my Postgres information. And I wanted to show it to you both ways. You can use just a full connection string, which I did for the MongoDB example, or if you wanted to break it down into individual properties, like for the Postgres example here, I broke it down into the user, the host, the database, password, port, etc. So the fields that you'll need to add are here. The port one is optional. If you don't set a port, by default, it's going to go to port 3000. And then all of the code that we write is going to be in this index.js file, which is going to be a simple Express application that we'll use to run and execute our queries with. And to walk you through that code, the first thing we're going to do is require the .env package and run it, which is going to go and load that environment variable and load our connection strings for the managed databases. Next, we're going to bring in our dependencies. So we're building an Express application, so we'll use Express. We'll be working with MongoDB, so we'll be working with object IDs. And then we're going to bring in our Mongo client and our Postgres client. So this is the way to to bring in the Mongo client to our scope, and this is the way to bring the Postgres client. And I opted not to use any ORMs or ODMs libraries for these examples. So we'll be writing pure MongoDB queries and pure SQL queries, as opposed to relying on like an object relational mapper to handle the models and handle the data for us. Once we have our dependencies brought in, the next thing we're going to do is set up our MongoDB client by getting that MongoDB URI environment variable, and then creating a MongoDB client by using the new Mongo client command and passing in the connection string. A similar thing for the Postgres client. We're creating a new client, passing in all of the environment variables, and then calling the pgclient.connect method to establish a connection. And then we set up our Express application. So app is going to be Express. And we set our port to either the environmentally set port, or if no port is set, we're going to default to 3000. And then I have a couple of sample routes here created. The home route is just going to say hello from DigitalOcean deploy. I have a MongoDB customers route, which is going to go into the customers collection, into the, actually, it's going to go into the deploy store database, into the customers collection, and it's just going to find all the records, but we're going to limit it to the first 10. Since this is going to be an array, we have to call the toArray method, and then we're going to respond, basically return to the browser those 10 documents in JSON format. Since this is a try catch and we're using async await, if we do get an error, we're just going to send that error out. And then we have a second route for Postgres customers. So the route is pg-customers. Again, it's an async route, and we're using the Postgres client to query our database, to go into the customers table and get the first 10 records that show up. And we're going to return JSON data to our browser in the format of data.rows. And then we are kicking off our application, starting it with the port that's provided. And we're going to say, once the app is started, that the app is listening on port, whatever port we set it to. So I'm going to stop the application and run it by executing node index.js. And we get the message that app is listening on port 3000. So now we can go and try these routes to see if they work. So I'm going to go into my browser here, and let's go to localhost 3000. It's the home page, and it's going to be just that message, hello from DigitalOcean deploy. And like here, yes, the recording will be available probably over the next couple of days if you are interested in joining or following up. Cool. So we have our base route, and this hello from DigitalOcean route. It doesn't make any calls to the database. It just returns a string message. But let's go ahead and make a call to MongoDB customers. And this route is going to return data. And actually, I'm going to do this in this browser window, just because I have an extension that parses the JSON and makes it a little bit easier to read. Here, so MongoDB customers route went into our managed MongoDB database on DigitalOcean and got the first 10 records and returned them to our application, and our application sent it to the browser. So our MongoDB client is set up correctly and works. Let's try our Postgres one. So we'll say pg-customers, and we get a similar response, but now we are getting the rows from the Postgres table. So we get the ID, we get the address, street, city, state, zip code, as well as the full name of the customer. So far so good. So both of our routes work, both of our clients are connected, and we can now write additional queries and interact with our data. And in my case here with the Postgres one, I basically got the rows that were returned and just sent them directly to the browser. But you may want to transform this data before serving it in JSON format, just to, this address field, we might want to actually make this an object rather than, address underscore street, rather than having like a flat representation of the data. But again, that's left up to you as the developer. Now let's write a couple of additional queries and show you how you can do that with both MongoDB and Postgres. So here, let's say we wanted to write an additional query or add an additional route. We'll just say we'll do a get route, and we can, or let's say we wanted to add a customer, right? So we can say add customer. Let's say add customer. We can write this query. And And if we wanted to do the same, we can do app.get Postgres add customer. Make it an async route. And then add our logic in here. We have this PG client, which is going to always be available. As soon as we start the application, we call the PG client, we call the connect, and that's going to keep the connection pool open in our application, so that as we write additional queries, as we write additional functionality, we don't have to go and connect to the database every single time. So if we wanted to add data with Postgres, we could do a try catch again. If we get an error, we'll back the error. But if we wanted to add the data, we can say const result set to, and I'm just doing a check on time. We'll say PG client query, and then we write our query in here. So let's do that, and then we'll response JSON our result. And our query could be as simple as insert into the customers table. And let's just say we wanted to add an ID and the full name of the customer, and not all of the information. Like, let's say we didn't have the address of the customer. So just make sure and see how the full name property is represented. So it's full underscore name. And we'll say values. So our ID, say 1, 2, 3, 4, 5. And the full name could be, let's say, Aishika, who has been really great in helping me moderate this chat and sending questions. So by doing this, we can insert data into our customers collection. So let's see if this works. So I'll restart the server, and the route is pg-add-customer. So we'll go into our browser, pg-add-customer, and we get the result saying that the command that we ran was an insert, row count was 1, and we specifically didn't ask to get the data back, but we can see that the number of rows that were affected was 1. So if we go back into our code here and we try to find this particular customer, if we try to find Aishika, we can update our PG customers query to say select all information from customers where full underscore name is Aishika. Save that. Let's restart our server and see if we're going to get that data back. So I'll go back into my browser here, PG customers. You can see that new record with the ID of 12345 and the full name of Aishika. So right now we have our managed database in DigitalOcean that's handling all of our data for us, right? We can just write queries against this database, store items, delete items, remove items, and so on and so forth. And also, Akhil has been very great in helping me as well. So let's add him to the Postgres example, to the MongoDB example. So we'll go into the MongoDB add customer. We'll write a try catch again, just in case we get an error. And let's see. So we'll say const result equals, and again, since both of the MongoDB clients and the Postgres clients return a promise, we can use async await to run the query and then once that promise has resolved, store it in the result, and then we'll send that back. So we'll say MongoDB client.database that we're working with is deploy store. The collection we're working with is customers. And what we're going to do here is instead of find, we're going to insert one. So we want to insert a single document. And the fields that we're going to insert are full name, which is going to be Keel. And the cool part about working with MongoDB is that you, by default, you don't have to, a data model is not strictly enforced. You can absolutely, if you wanted to, enforce a schema in MongoDB, but if you didn't want to enforce a schema and wanted to be able to add additional information to your MongoDB collection, you could do that by just adding an additional field. So we'll say, what Akil's job is, being awesome moderator. So we have our insert one into the customers collection, and we don't have to specify the _ID field by default. We can, MongoDB will automatically add one for us if we don't pass one in. So MDB add customer. That looks good. And then let's just return the result of that operation. So I'll restart this again. MDB-add customer. So MDB-add customer. And the result we get back here is acknowledged true, which means that MongoDB received this data, it wrote it to the disk, and then it said, it was saved successfully and we're good to go. And it also returned back the ID for Akil. So if we want to find him in the database, let's just update this MDB route. And in this case, we'll say find one with the _ of ID, new object ID is going to be the ID that was returned to us. And since it's a find one, it's just going to return one document, so we can get rid of the limit and to array, save, restart our server. Now if we run MDB customers, we're going to get Akil, his full name, as well as his job of being an awesome moderator. So that's one of the cool things about MongoDB. You can add any sort of additional fields to your documents as you see fit. And then, when you're quickly prototyping an application, when you're quickly trying to add features or test things out, this is a great feature. Whereas, with Postgres, with SQL databases, you are strictly limited to the rows, to the columns that you define. And if you wanted to add this job property to, add this job column, you would first have to add it in the database, modify the table, and then only then could you add additional properties. Let's see. So I think that is good. I guess one other query that I'll show you how to do is a MongoDB aggregation in the code, and then we'll kind of open it up for Q&A as we wrap up the workshop. So let's go back into our code, and below here we'll add a new route called app.get, and we'll call it MDB aggregation. And we'll make this an async request again. And actually, I could just copy some of this boilerplate code, and we'll remove this stuff. Right. Let's see. So we'll say data. And in our example here, we're going to work out of the orders collection. And what I want to do is figure out, based on all of the customers that we have, all of the customers that have placed orders, how many orders each unique customer has placed, as well as what their total spend was, how much money they've spent in the store. And I'll show you how to very easily do this with MongoDB aggregations. So instead of doing a find or an insert operation, what we're going to do is an aggregation. So we're going to call the aggregate method. And the aggregate method takes in a pipeline, which is an array of objects for the various stages that we want to operate on. So what this is going to look like is, first we're going to do a group stage. And what the group stage is going to do is it's going to allow us to group our orders by an attribute that we define. And our group is going to be based on the underscore ID of the customer full name property. So we're going to be grouping this on each unique customer's full name. And I know, in a real world scenario, you'd probably want to do this on a customer's ID instead of their full name. But, for demo purposes and for educational purposes, I think full name will work fine here. And what we want to do is add 2 additional fields to this grouping. So we'll say total orders, and this is going to be the total number of orders that the customer has placed in our store. And to get this, we can just run the count operation without passing in any additional fields. So what this is going to do, and I'm just missing a comma here. What this is going to do is it's going to go into the orders collection, combine all of the customers based on their name, and then count how many times each customer's unique name comes up. And that's going to give us the number of total orders each customer has placed. Additionally, we want to see how many total individual items that each customer has placed. So we'll add that additional field. We'll say total items purchased. And to get this, we're going to run a sum operation on the items array. So if we look at our data model, it might be easier to see. So each order has a customer and it has the customer's full name. And then the items array has how many individual items they've purchased. This customer for this particular order has placed 8 items. This customer has bought 5 items, and so on and so forth. So we're going to sum on the size of the items array. And that's going to give us the total number of individual items purchased across all orders for a unique customer. And then finally, we'll do the total dollar spend. So we'll say total spend. To get this, we're just going to sum up the total value, so the total value field, for each individual order. And that is the only stage that we need to have in our aggregation here. We could add additional aggregations and additional fields, but I think this is good enough. So we'll save this. Autocomplete or IntelliSense kind of cleaned up our code for us. I think it was prettier actually. And let's see if this works. I will restart the server, and our route is mdb-aggregation. Go into our code and say mdb-aggregation, remove the extra slash, and it failed. The demo gods are not with me, but let's see if we can debug what happened. So events, event count, customer full name, total orders is the count. Oh, I think we also need to, it's an array since we're getting back all of the customer's information. So try this again. And it looks like it's working. It's probably going to take a couple of seconds just because we have over 250,000 orders. And yeah, I mean, that query still ran in about 2 seconds, but we can see that, and actually, let's do one more thing. So we have our group stage here, which did all the groupings for us, but we can add an additional stage to limit, and let's say we just want to limit it to the first 10 records, or like the first 10 unique customers. That'll make it a little bit easier, and it'll allow the JSON parser to parse the data, make it easier to see. So we'll refresh this. Aggregation, and now we can see that we're only getting 10 records back, and we can see that, you know, Bruce has placed 2 total orders, bought 12 items, and has spent $6,413. Sadie has also placed 2 orders, bought 12 items, but spent $7,500. Francis, 2 orders, 11 items, and so on and so forth. So that is one of the great capabilities of MongoDB with the aggregation framework. And I know you can do similar things with SQL as well, to really transform your data and make it work for you. And it still executes really, really quickly. And, you know, we don't have to worry about this maintenance. We can go into our dashboard and see our logs, see the calls that were made, see the insights on those logs, and just kind of keep track of how our application is being used, how our disk is being filled up, and stuff like that. So with MongoDB managed databases, you are allowed to just deploy this database and focus on writing your application code, writing your application, adding features, writing queries, instead of doing the hard work of standing up and managing your own database, making sure that it's up and running, that it's protected. And just to show you that trusted sources also works, I have the application deployed here in the deploy workshop. I have an app platform app called Orca app. And if I open it up here and navigate to it, it is that same application, Hello from DigitalOcean. And if I go to MDB customers, I get the first 10 customers, but that is because I've enabled access to the Orca app from my MongoDB cluster, right? If I go into the trusted sources here, I can see that my local development environment and the Orca app platform application can talk to my database. But if I didn't want that, you know, if I say I only wanted, and you know, this is a good thing to do in production. If I made my application live and I didn't want my local development environment or my local developers to be able to access the production database, I can simply just remove access here, save it, and now only my deployed application hosted on that platform within DigitalOcean can call my MongoDB queries. If I go and refresh the page here, it'll continue to work just as it has in the past. But if I go to my local browser and try to run this aggregation, it's not going to work, right? It's going to fail because I no longer have access to that database. So let's go check and make sure that that works and that it's not cached. So if we go MDB customers, now the application is hanging because it cannot load that data because it doesn't have access to the server, and eventually it's going to time out and tell me that it couldn't connect to the server. Same thing with GUI tools. Here, if I try to go and disconnect and reconnect, I am going to eventually get an error saying that there's a timeout. You couldn't connect to the MongoDB cluster because we enabled those trusted sources to limit. I was just reading a question. But yeah, so here we are trying to connect to that MongoDB database, but since we only enabled our app platform application to talk to it, we're not going to be able to access it. And you'll see the connection e-timeout at that particular port. So that's all of the prepared content I have. I know we only have about 10 minutes left, so I did want to open it up for any questions about managed databases, about MongoDB, about Postgres. And I will, in the meantime, while questions come in, let me check on that PostGIS question that somebody had earlier. So So I'm reading a reply here, and it looks like PostGIS is an available extension. And let me see how you can enable it. But please continue to add any additional questions while I look this one up. All right, cool. So I was actually able to find in the documentation how you can go about enabling the various PostgreSQL extensions as well as all of the supported ones. So I have just pasted that in the chat. And yeah, there is a lot of supported PostGIS is there, as well as PG cron, ISN, Bloom, and many others. So check that doc out, and it'll show you how to enable and disable extensions as well. Beverly has asked, refresh the GitHub code with what you have written. I can absolutely do that. Let me publish it here to the GitHub repo. Let's do a new branch. Workshop end. Branch, switch to it. And restore. Bring the changes over and commit it. So now if we go into the GitHub repo here, there should be a workshop end branch that is going to have all of the updated code. So I will share that in the chat as well. And if you have any questions, please feel free to reach out to me either on Twitter at Kukic Auto or at my DigitalOcean email, akukic@digitalocean.com. So I'll share both of those in the chat. And let's see if there's any other questions. Is there a plan to have redundancy on more than one data center? So if a DigitalOcean data center has problems, the DB won't be down for our users. That is a great question. And at the moment, there is not, in the UI, you can't enable a database to span across multiple regions or multiple data centers, but that is a feature that I think would be really nice to have, and I'll share that with the product team as well. And then what is the expected downtime for a DigitalOcean MySQL managed database node failing with a 0 spare node and with a spare node? Another good question. So I haven't looked into the MySQL redundancy, so let me follow up on that question as well, and we'll be happy to share an email out after the fact with some literature on that. This is a good question, and one I can help with because I ran into it myself. So using DigitalOcean MySQL managed database, we got problems with default Laravel migrations because SQL required primary key variable is set on DO instance. Is there plans to solve this issue with Laravel or petition Laravel to change the default migrations? So currently using the API, you can disable this SQL required primary key variable. So if you go into the DigitalOcean API docs, right here, DigitalOcean API, into the database section, let's see, databases, and update database configuration. So by default, we set this SQL require primary key to true. If you make a call to v2 databases, your database cluster UUID, and then the config, you can set the SQL required primary key attribute to false, which will solve this problem. So I'll share the link in the chat as well if that's something, that's one workaround to deal with this SQL required primary key issue. Let me follow up on that one. I'm not sure if it will or not. Happy to look into it though. And I think we are right up on time. So thank you all so much for joining today. I hope you had a great Deploy conference, and I hope you have a great rest of your day. Please join other sessions as we wrap up Deploy today, and I hope you have a great rest of your day. Thank you all.